Right now, new and current customers can get any phone for free at US Cellular, so you can connect with all your family members this holiday season. You could even call your aunt who always makes you talk to your cousin, who's a dog. Or, maybe just send her a festive text. Get the gift of connection at US Cellular. Get any phone free today. US Cellular, built for us. Terms apply. Visit uscellular.com for details.
We value human connection with fewer distractions. US Cellular, built for us. Visit your US Cellular authorized agent, Cellular Advantage, located at 918 South Locust Street in Glenwood.
Now, during the Jeep Black Friday sales event, get $12,500 in lease support on the 2023 Jeep Grand Cherokee Overland 4xE. $12,500 lease support includes cash allowances and $7,500 federal EV incentive provided by lender as a capitalized cost reduction and is subject to change without notice. Lessees cannot claim federal tax credit on their personal tax return. Please confirm this information to ensure its accuracy and availability. Consult a tax professional for details and eligibility. Not all lessees will qualify. Residency restrictions apply. Take delivery from dealer stock by 11/30. Jeep is a registered trademark.
This is SpaceTime, Series 22, Episode 95, for broadcast on the 25th of December, 2019. Coming up on SpaceTime, Boeing's new Starliner fails to reach the International Space Station, the largest stellar mass black hole ever detected, and scientists select a site on asteroid Bennu for sample collection. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Boeing has failed in its first attempt to send its new CST-100 Starliner crew capsule to the International Space Station, instead getting the spacecraft stranded in a useless orbit. Mission managers from Boeing and NASA say a computer software glitch triggered a mission elapsed time anomaly, which caused Starliner to think it was conducting an orbit insertion burn when it really wasn't. That saw the spacecraft perform a series of unnecessary orientation-maintaining maneuvers using its reaction control thrusters, which wound up expending far more propellant than planned. Ironically, had the flight been manned, the crew could have overridden the faulty computer and conducted the crucial orbit burn manually, thereby setting Starliner on its correct course to intercept the International Space Station as originally planned. The unmanned flight, called OTF, or Orbital Test Flight, was to have been the prelude for the return of American astronauts flying to the space station on American rockets launched off American soil. NASA's been forced to rely on Russian Soyuz rockets flying from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan ever since the retirement of the Space Shuttle fleet way back in 2011. Starliner was launched aboard an Atlas N-22 rocket, the first of this type to fly. Mind you, the N-22 is essentially nothing more than an Atlas V 421 booster fitted with a modified Centaur upper stage, equipped with additional monitoring systems and computers for manned spaceflight, as well as dual Aerojet Rocketdyne RL-10A engines rather than the usual single engine. The mission launched into pre-dawn skies from Space Launch Complex 41 at the Cape Canaveral Air Force Station in Florida, with Starliner being released from its Centaur upper stage into its transfer orbit roughly 15 minutes after launch.
Status check.
Go Atlas. Go Centaur.
Go Starliner.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff. The rise of Starliner and a new era in human spaceflight.
Clear the tower. Vehicle's begun the pitch over program. Body rate responses look good. VU's gone to closed loop control. RD-180 looks good at full thrust. RD-180 now throttling down to partial thrust as expected. Engine operating parameters continue to look good. Vehicle is now passing through max Q, maximum dynamic pressure. Chamber pressures on both SRVs continue to look good. RD-180 engine operating parameters also continue to look good. And Mach 1, Atlas V is now supersonic. And vehicle now throttling up. Engine response looks good. Continue to see good chamber pressure on both SRVs. Body rate responses on the vehicle look good. 1 minute 30 seconds in, standing by for SRV burnout. And we have burnout on both solid rocket boosters. Atlas will hold on to the SRVs for an additional 48 seconds prior to jettison. RD-180 has gone back up to full thrust as expected. Engine response looks good. Atlas is now 17 miles in altitude, 11.5 miles downrange distance, traveling at 2,300 miles per hour. RD-180 engine operating parameters continue to look good at full thrust, and at 2 minutes 11 seconds into flight, the Atlas rocket now weighs just 1/2 of what it did at launch, burning propellant at a rate of 2,800 pounds per second. And we've seen good indication of jettison of both solid rocket boosters. Vehicle's gone to closed loop guidance. Engine's now throttling down slightly. Engine response looks good. And Atlas V is now traveling at over 5 times the speed of sound. Centaur reaction control system is now pressurizing to flight levels. System response looks good. Atlas V is now 38 miles in altitude, 80 miles downrange distance, traveling at 5,800 miles per hour. Body rate responses continue to look good throughout the booster phase of flight, and RD-180 is now throttling to maintain a constant 3.5 G acceleration limit. Engine responses will all look good. And Centaur's begun the boost phase chill down sequence. RD-180 continuing to look good as it throttles to maintain that constant 3.5 G acceleration limit. Atlas PU has gone to open loop in preparation for BECO and standing by for BECO. And we have BECO booster engine cutoff, standing by for stage separation. And we have good indication of stage separation. We have pre-start on the RL-10, standing by for ignition. We have ignition and full thrust on both RL-10 engines. Chamber pressures look good on both engines.
We have confirmation of ascent-covered jettison on Starliner.
Aeroskirt jettison. And we have good indication of aeroskirt jettison. Centaur now resuming active attitude control after successful aeroskirt jettison. Chamber pressures on both RL-10 engines continue to look good.
This was a very critical piece of the mission here. Staging is always a very dynamic piece of flight.
And the Centaur RCS system is beginning the initial thruster firings for system thermal conditioning. System response looks good. And Centaur is now 95 miles in altitude, 570 miles downrange distance, traveling at 12,000 miles an hour.
Those dual RL-10 engines continue to propel Starliner. They are making up for a little bit of the booster flying a flatter trajectory and at lower thrust, again, to maintain that 3.5 G forces. Again, a first flight for the dual-engine Centaur on an Atlas V. Starliner and Centaur continue to head to orbit.
Throughout this Centaur burn. And Centaur is now 102 miles in altitude, 800 miles downrange distance, traveling at 12,700 miles per hour. And the Centaur propellant utilization system, continuing with active control, looks good. Body rate responses are all very close to null.
That means Atlas is flying almost exactly where it needs to be.
Now passing 8 minutes into flight.
If you are just joining us, 8 minutes into Starliner's first flight. We've been through a successful booster stage separation. Centaur continues to propel Starliner. The next major milestone will be main engine cutoff at 11 minutes and 58 seconds.
Both Centaur RL-10 engines are continuing to perform well throughout the burn. Chamber pressures look good. Centaur is 101 miles in altitude, 1,200 miles downrange distance, traveling at 14,300 miles per hour. Centaur system performance remains nominal throughout this burn, continuing to see stable values on our fuel and oxidizer tank pressures, main vehicle battery temperatures and pressures, and continuing to see good pressures on our helium and hydrazine storage bottles. Telemetry quality has been good throughout this burn, only seeing very brief minor dropouts.
After Starliner separates from Centaur, Starliner will circularize its orbit with an orbital insertion burn.
The pressures on both RL-10s continue to look good.
Now, ahead of main engine cutoff, we are seeing good tank pressure on Starliner itself. Batteries are in a nominal temperature. Good pressure sensor readings from Starliner as it prepares to free fly for the first time in orbit.
Standing by for main engine cutoff. And we have MECO, main engine cutoff. Body rate responses have remained very stable. Now passing 12 minutes into flight.
Now Starliner will stay attached to Centaur again until about 15 minutes. Expected to separate at 14 minutes and 58 seconds after liftoff. And that will be the first time Starliner free flies in orbit. And at that point, Richard Jones and his team in Houston will have full control over the vehicle. And they will set it up for an orbital insertion burn that will take place 16 minutes after separation.
And about 1 minute now remaining until OFT separation. Now standing by for spacecraft separation. And we have good indication of separation of the OFT capsule.
There it is. ULA has successfully completed their piece of the mission. Starliner is free flying for the first time in space. From here, the Johnson Space Center mission controllers will be flying Starliner.
And Starliner's software has been switched to orbit mode, meaning the spacecraft is executing the commands it needs for operating in space following a successful launch into orbit, into the orbital trajectory. This is just one step flight controllers are taking in configuring Starliner now that it's flying on its own. Flight controllers are setting up for the orbital insertion burn, which will take place in about 15 minutes, a little over 15 minutes. And that'll circularize Starliner's orbit as it sets off to chase the International Space Station. The team here is also turning off several systems that were needed for powered flight but are not necessary now that Starliner is in orbit. While some are turned off, others will be turned on, such as the thruster housings that'll be used to maneuver Starliner in space and the solar arrays. The thrusters will steer Starliner through orbit, and the solar arrays will, of course, convert the sun's energy into electric energy to charge the spacecraft batteries.
The Centaur has intentionally left Starliner in an elliptical trajectory that would make it easy for the spacecraft and, more importantly, its future crews to come back to Earth at this point if there were a problem. But that means it's all on Starliner to make it the rest of the way into a stable orbit and on track for the space station docking. This is where Starliner's orbital maneuvering and attitude control engines come into play. Those 20 engines can provide each up to 1,400 pounds of thrust, which is more than enough to neatly heave Starliner that last little bit into orbit. They'll fire for about 40 seconds, setting Starliner on the right path not only for docking with the space station, but also a series of demonstrations that Starliner will perform before docking.
And controllers are maneuvering Starliner into the right attitude for this orbital insertion burn. Controllers watching the systems, and the orbital insertion burn has been delayed. Controllers are watching the attitude of Starliner as it positions itself and looking at the spacecraft in flight.
Once again, that orbital insertion burn's been delayed as the team here on the ground is seeing Starliner not in the correct attitude for it. They're working through that.
The flight was to have paved the way for manned missions to the space station early in the new year. Boeing's one of two companies contracted by NASA under its Commercial Crew program to develop manned capsules designed to ferry crews to the space station and back, thereby allowing NASA to focus on deep space missions using the new Orion capsule and SLS rocket, which will fly a crew to the moon and eventually onto Mars and beyond. The other company, SpaceX, successfully carried out its version of an unmanned orbital test flight called Demo 1 back in March, flying its Crew Dragon 2 capsule to the space station aboard a Falcon 9 rocket on a 6-day mission. The Commercial Crew program was designed as a natural follow-on from NASA's Commercial Resupply program, which has seen SpaceX Dragon and Orbital, now Northrop Grumman, Cygnus cargo ships carry supplies to the space station since 2012. That program's now been extended and will include a third company, Sierra Nevada, flying its Dream Chaser spaceplane. Dream Chaser will carry up to 5 tons of cargo on resupply missions to the space station from 2021 using the new United Launch Alliance Vulcan Centaur rocket. Starliner was slated to reach the space station 25 hours after launch, docking onto the forward-facing Harmony module. The flight was carrying an anthropomorphic test dummy nicknamed Rosie, as well as some 270 kilograms of fresh supplies, mostly food, but also some crew clothing and radiation monitoring equipment. Starliner was slated to remain docked with the space station for 7 days before returning to Earth. You're listening to SpaceTime. Coming up next, the largest stellar mass black hole ever detected, and later scientists select a site on the asteroid Bennu for a sample collection for return to Earth. All that and more still to come on SpaceTime. Astronomers have observed the largest stellar mass black hole ever detected. The black hole, catalogued as LB1, has about 70 times the mass of the Sun. That's more than twice the size of any previously detected stellar mass black hole. The findings, reported in the journal Nature, indicate the black hole was observed within our Milky Way galaxy, just 15 light-years away from the Sun. That makes it really local. Stellar mass black holes are formed out of the collapse of the most massive stars, or through the mergers of 2 neutron stars, the stellar corpses left behind by the collapse of stars far more massive than the Sun. One of the study's authors, Professor Alexander Hedger from Monash University, says the newly discovered black hole is young, just a few million years old at most, and it was found relatively nearby, unlike those more distant high-mass stellar mass black holes discovered in distant galaxies by LIGO, the Laser Interferometer Gravitational Wave Observatory. It's a fascinating discovery because astronomers have often wondered just how big a stellar mass hole can get. Hedger says the current view is that most stars in our galaxy couldn't easily make a stellar mass black hole any bigger than 45 solar masses. But of course this one's more than 50% larger than that limit. Most current models of stellar evolution suggest that stellar mass black holes of such mass simply should not exist in our galaxy based on the metallicity, that is, the composition of likely progenitor stars in our part of the galaxy. Scientists will now need to explain its formation in a solar metallicity environment. Metallicity simply refers to any element other than hydrogen and helium, the 2 elements formed in the Big Bang 13.8 billion years ago. Hedger and colleagues made their discovery while observing the sky with the Lammost optical telescope in northeastern China, looking for binary stars orbiting around invisible companions. The Lammost telescope allows astronomers to find binary star systems and provides a better understanding of the fates of the most massive stars and the black holes they make. The authors knew something was up when they detected a star some 8 times the mass of the Sun orbiting around an unseen companion every 79 days. Only 1 in 1,000 stars are likely to be orbiting a stellar mass black hole companion, making the task of detection extremely difficult, and in this case, fortuitous. Hedger says the big task now is to undertake detailed follow-up observations using a wide range of both ground and space-based telescopes.
The interesting discovery was that it was a rather big black hole of around 70 times the mass of the Sun. So the way it was found is quite interesting. It was what's called radial velocity variation. You can see how some spectral lines that you see also in the Sun, how they shift as a function of time. And this is a typical indication that things moving around in some orbit is basically the same kind of method that people have been using to detect planets, like the discovery of the first planet that was done in a very similar way, where you just had the Nobel Prize this year. So the same kind of technique.
That was Pegasi 51.
Yes, Michel Mayor and his team found.
And you've used the same Doppler shift technique to find a star which is orbiting what, based on its mass, is probably a black hole.
Right. So normally you just see a very small tuck and the planet is moving around a star, but in this case, they caught a really big fish. They caught the black hole from the motion. So it's a much bigger motion because the black hole is a lot heavier. But you see that motion, and then you can, with a lot of other things that you need to figure out as well, you can eventually deduce the mass of the object.
And this is where it gets really interesting, isn't it? Because you've got to also try and justify how something so big could have come from a star in our galaxy, given the average metallicity of the region it was found in.
Yes. So the key paradigm, or the idea that we have about stars in our galaxies, when they get very big, that they have very hefty winds, and we observe this in part that there's huge mass outflows, and so we expect that most of the stars that are young stars in our galaxy, that they have already a lot of this nuclear waste, you call it metals, everything that's heavier than hydrogen or helium. That's the residual of stars. You get more and more dumped in all of the gas and all the stars that you make out of it, but it also leads to that the stars then blow off more mass as they evolve. And so the standard idea that astronomers have is that this prevents you to make such kind of big black holes in this mass range. But there's two things that the star, first of all, has to hold on of this mass, and then secondly, there is some predictions from our theories suggest that when a star reaches the end of its life with this kind of mass, and it's mostly made out of helium, that it would actually puff up most of the mass before, so you would not be able to get into this mass regime with our standard theories. And so finding something there is kind of a contradiction to what we assume knowing about how black holes form or how big stars actually evolve at all in our galaxy. And so far we have seen some big black holes, but only about up to about 15 or 20 solar masses. So something this big in our galaxy has not ever been seen. When there's much bigger black holes, there's the big black holes in centers of galaxies. There are millions of solar masses, but they are not directly made. So in this case, there's a small star next to it, so we know it's a young black hole. It has just been formed there within a few million years. And
tell me about the sort of progenitor that would be required to make a 70 solar mass black hole.
Well, that's the question we don't know.
It's great, isn't it? It's always interesting when you see something and you can't explain it, and you've got to sort of work out, what could possibly do this.
Yeah, there's of course some people have ideas here and there, but they have many other issues that come along with it, because you see that many of these big stars should lose all of their mass, so it's hard to figure how you can hold onto it to make this kind of black hole. And there's other features as well, that if you assume the star loses lots of mass, and for example, especially if it shoots out the mass in some kind of big eruption, then if you have a binary system, that would get some kind of kick and be an eccentric orbit, what we call it, so no longer circularly moving around. But this system is basically almost perfectly circular orbit, so that also says that, okay, something really strange has happened here.
What about the companion star? What is that?
So best estimates is that it's at about 8 solar mass star. Blue star, somewhat evolved. Yeah.
So spectral type B star or something like that.
Yeah.
We have seen black holes this big elsewhere in the universe. LIGO has picked up a number of them, and some of them are the death of stars, others or at least one other, from the merger of two neutron stars.
Yes, so what people have seen is that you had initially black holes that were up to maybe 30, in one case maybe 45 solar masses, and these have merged together to make some big black hole that would be compatible to this one that we see here, but this is just after the a merger. But in this case, it seems more likely, okay, there's some single black hole there, and this is somewhat different. So these are only black holes that we see the formation. We never see the resulting black hole by itself afterwards.
And this particular black hole is relatively nearby in astronomical terms. Does this mean it's a good target for future study?
So yeah, it will be. It's within reach of other observations, so we can look at this more, and it will be done. Yeah, the other telescope will look at it. We'll try to figure out more about it and what we can do to improve the measurements that we have so far, and possibly put in tighter limits on everything.
This is the first one you guys have found. I take it won't be the last you'll be hunting for.
Yes, LAMOST is a multi-fiber spectrograph, so they look at many of these systems, and the hope is that they will find many more this way. But there has been another small black hole. It's also been seen recently with some radial velocity variations.
Yeah, that was the 3.3 solar mass black hole. That was an interesting story, because we now think the neutron degeneracy limit is around 2.3 solar masses. And so 3.3 wouldn't be unusual, would it? If 2.3 solar masses is sort of where neutron degeneracy occurs.
Well, we don't really know. I think there's many uncertainties on these limits. So I think firm limits are just above 2 solar masses still. I think, yeah. The other ones, they have error bars, and they may still be compatible with something slightly above 2. This is all, you have to always take all of these measurements with some grain of salt. There's always error bars associated with it as well. And you can see, okay, what's the confident regime that you have. But yeah, making black holes on the other side at more than 3 solar masses, that's not a problem at all. It was rather surprising that we hadn't found anything like that before. So that was also considered a mass gap. Whereas this new black hole, it's not really a strict mass gap because it depends on how the black holes form with the low mass. And the much bigger problem is the one at the big masses in this limit, where we think that stars that end their lives around 70 solar masses without an envelope, they would just explode or puff up the outer layers until they are shrunk down to maybe 40 to 50 solar masses. So that's the big issue with this new discovery, that the black hole is in sort of forbidden region where at least single star evolution couldn't get you to easily. Even if you could make a star that is 70 solar masses, which we have severe doubt, then it would still, make a 70 solar mass star at the end of their life, then it would still shed off all of this mass or explode, and instead of making a black hole. So that's the big issue with this discovery, or the interesting part about it.
And of course, it still doesn't answer the other question: where are all the intermediate-sized black holes?
By intermediate size, you mean
those of a few hundred solar masses to a few thousand solar masses? We just don't see any of them.
Well, the question there is whether you ever had such big stars. So it might, this would have come possibly from the early universe.
Population 3 stars.
Correct. Yes, the first generation stars. So there, we haven't seen these stars themselves, but we estimate they would be big. But again, we don't know what the final fate of these things is. These stars is as they reach the end of their lives. So we don't even know what they really should be doing in our own galaxy, and therefore, let alone, and in our own galaxy we have observations in the present universe, and we can't tell for sure. And of course, when we go back to the first generation of stars, something like 13 billion years ago, we know a lot less what happened back then. We can't see it, observe it directly.
Well, the very oldest stars we've got in this galaxy are population 2 stars like Methuselah and others like that, and they may have been made out of the stuff which was blown off by the first generation of stars.
Yes, that's correct. So they're made up of some traces of the material from this first generation, and the hope would be that we can see that we use this chemical abundance patterns or chemical imprint or fingerprint that they left behind to tell what the progenitor stars was, because we think that depending on what the nature of the star was, its mass, it would leave a different kind of composition fingerprint.
That's Professor Alexander Hedger from Monash University in Melbourne. And you're listening to SpaceTime. I'm Stuart Gary. Nightingale has been selected as the primary collection site for NASA's Osiris-Rex sample return mission on the surface of the boulder-strewn asteroid Bennu. The Nightingale site is located in a crater high on Bennu's northern hemisphere. Osiris-Rex mission managers spent several months evaluating close-range data from 4 candidate sites in order to identify the best option for sample collection. The candidate sites, named Sandpiper, Osprey, Kingfisher and Nightingale, were chosen for investigation because all had potential sampling regions posing the fewest hazards for spacecraft safety, while still providing an opportunity for gathering geologically interesting samples. Osiris-Rex principal investigator Dante Loretta from the University of Arizona in Tucson says the final decision was based on which site had the greatest amount of fine-grained material and how easily a spacecraft could access that material while still remaining safe. Of the 4 candidates, Site Nightingale best met these criteria and ultimately best ensures mission safety. The Nightingale site is located in a 70-metre wide crater. Nightingale's regolith or rocky surface material is dark, and images show that the crater is relatively smooth. Because it's located so far north, temperatures in the region are lower than elsewhere on the 450-metre wide asteroid, and surface materials are well preserved. The crater is also thought to be relatively young, and the regolith is freshly exposed. This means the site would likely allow for a pristine sample of asteroid material, giving the team the best insight into Bennu's history. Although Nightingale ranks the highest of any location on Bennu, the site still poses challenges for sample collection. You see, the original mission plan envisioned a sample site with a diameter of at least 50 metres. Now, while the crater that holds Nightingale is larger than that, the area safe enough for the spacecraft to touch is much smaller, just 16 metres wide. No one expected the surface of Bennu to be quite as boulder-strewn as it is. And these boulders are by no means pebbles. They range in size from something as big as a golf cart to something as big as a decent-sized house. All this means the spacecraft will have to be very accurately targeted onto Bennu's surface. In fact, Nightingale has a building-sized boulder situated on the crater's eastern rim, which could pose a serious hazard to the spacecraft while backing away after contacting the surface. All this means the spacecraft will have to be very accurately targeted onto Bennu's surface. Mission managers have also selected Site Osprey as a backup sample collection point, just in case. You see, Osiris-Rex was designed to undertake multiple sampling attempts, but any significant surface disturbance on the Nightingale site would make it difficult to collect a sample from that site again on a later attempt, making the need for a backup site necessary. The spacecraft's designed to autonomously wave off from a site if its predicted position is too close to what's deemed a hazardous area. During this maneuver, the exhaust plumes from the spacecraft's thrusters could potentially disturb the surface of the site due to the asteroid's microgravity environment. Any situation where a follow-on attempt from Nightingale is no longer possible will trigger a redirection to sample from Osprey instead. The selection of the final primary and backup sites means mission managers will now undertake further more detailed reconnaissance flights over both Nightingale and Osprey over the next few months. Once these flyovers are complete, the spacecraft will begin rehearsals for its first touch-and-go sample collection attempt, which is slated for August. Asteroid Bennu was selected by NASA for the Osiris-Rex mission because it's a near-Earth object, meaning its orbit crosses the orbit of Earth, and it has one of the highest known chances of hitting the Earth, with a 1 in 2,700 chance of impacting our planet sometime between 2175 and 2199. So, understandably, scientists want to learn as much as they can about this mountain-sized space rock. Launched in September 2016, the 2,110-kilogram Osiris-Rex spacecraft arrived at Bennu in October 2018. The spacecraft spending a total of 3 years orbiting the asteroid, mapping Bennu's surface and geology, studying its evolution, its composition, chemistry and mineralogy. The probe will depart Bennu in 2021 and is scheduled to return to Earth in September 2023, ejecting a small sample return capsule designed to parachute down into the Utah desert for collection. This report from NASA TV.
In late 2018, as NASA's Osiris-Rex spacecraft neared its target, Bennu, the asteroid grew in detail from a few tiny pixels to an incredibly high-resolution image. Osiris-Rex confirmed the asteroid's basic shape, which was originally observed in 1999 by ground-based radar at Arecibo Observatory. What scientists didn't expect was just how rough and boulder-filled the asteroid would turn out to be. Another challenge for the mission is the asteroid's small size and weak gravity. This means that Osiris-Rex needs to fly daringly close to the surface in order to enter into orbit. With its orbital A phase, Osiris-Rex successfully entered the closest ever orbit for a spacecraft, setting a Guinness World Record in the process. Then, 6 months later, it beat its own record during its orbital B phase and approached to within a few hundred meters of the rocky surface. Because Osiris-Rex flew so closely over the surface during orbital B, the team was able to map the topography and shape of Bennu better than we have our own moon. In addition to mapping asteroid Bennu, Osiris-Rex plans to collect and return a sample back to Earth. To do that, the spacecraft will carefully tag the surface of Bennu. What was originally envisioned as a smooth and easy touchdown on Bennu's surface has become a complex endeavor to tag a small, crowded space on the asteroid, an area no larger than a few parking spots, by mid-2020. The Osiris-Rex team has already pushed the boundaries of scientific exploration, going from ground-based radar images all the way to being a few hundred meters from the asteroid's surface, and is now mere months away from a sample collection attempt.
This is SpaceTime. Coming up next, the Science Report, today covering the deadly wildfires surrounding Sydney and how pollution by China is preventing the ozone hole over Antarctica from healing over. All that and more still to come on SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a Science Report. Scientists studying the deadly megafires now surrounding Sydney and spreading over vast areas of New South Wales say the devastating blazes are largely the result of extreme drought, blistering record temperatures, and low humidity. The New South Wales Rural Fire Service says more than 96 bushfires are now burning, covering an area well in excess of 2.2 million hectares. Major wildfires are also burning in southern Queensland, Victoria and South Australia. Coupled with the dangers of the fires themselves is a massive shroud of billowing grey smoke which has been choking Sydney for weeks and has now extended 1,000 kilometres south to blanket Melbourne and over 2,000 kilometres to the east across the South Pacific Ocean to New Zealand and well beyond. The smoke is a mixture of particles and chemicals produced by incomplete burning of carbon-containing materials. It includes carbon monoxide, carbon dioxide, particulate matter such as soot, and other chemicals including aldehydes, acid gases, sulfur dioxide, nitrogen oxides, polycyclic aromatic hydrocarbons, benzene, toluene, styrene, as well as metals and dioxins. The type and amount of the particles and chemicals in the smoke varies depending on what's burning, how much oxygen is available, and the burn temperature. Scientists say the smoke Sydney-siders are now experiencing is equivalent to consuming 40 cigarettes a day, and that sparked major respiratory health problems, especially among infants, the elderly and the infirm. A new study warns pollution by China is preventing the ozone hole over Antarctica from healing over. The findings, reported in the journal Nature Communications, shows increased emissions of the ozone layer-destroying chemical CFC-11 by China is likely to delay the recovery of the ozone hole by at least 20 years. The production of CFC-11 was banned in the 1980s by the Montreal Protocol, but recently they've started to see a dramatic increase in the chemical because of industrial activity in China. Researchers found that the impact of the CFC-11 emissions on the ozone hole has so far been limited. But if the emissions continue to rise at current levels, it will dramatically delay the hole's recovery. A report on the well-being of Australian kids suggests most children are happy, healthy and safe. The report, called Australia's Children, brings together data about kids aged up to 12, covering their experiences at home, in school and in their general communities, along with a range of statistics. The good news is fewer mothers are drinking and smoking during pregnancy, and death rates for kids are among the lowest in the world. However, only 1 in 20 Aussie kids eats enough veggies, less than a quarter get enough exercise, and more than 2/3 spend far too much time staring at screens. And bullying remains a major issue for Australian children. In fact, in 2015, almost 3 in 5 9-year-old kids reported being bullied monthly or even weekly during the school year. A new study suggests Homo erectus, one of the close ancestors of modern humans, went extinct in Indonesia between 117 and 108,000 years ago. A report in the journal Nature by scientists, including researchers from Macquarie University, undertook the first comprehensive age study of the last known site of Homo erectus, which was a fossil bone bed at Nangdong in Java. The findings have wide implications for hominin evolution in island Southeast Asia and is critical for understanding hominin rivals, interactions and extinctions. A new study shows that dogs may have a sense of numbers. The findings, reported in the journal Biology Letters, are based on brain scans of dogs while flashing different numbers of dots on a screen in front of them. Scientists saw areas of the dog's brains light up when the number of dots changed, and they say those brain areas correspond closely with regions of the human brain that also respond when numbers were shown. All this suggests that a common neural mechanism has been deeply conserved across mammalian evolution. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favorite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram. On Facebook, just go to www.facebook.com/SpacetimeWithStuartGary, with Stuart Gary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Holidays start here at Baker's with a variety of options to celebrate traditions old and new. Whether you're making a traditional roasted turkey or spicy turkey tacos, your go-to shrimp cocktail, or your first Cajun risotto, Baker's has all the freshest ingredients to embrace your traditions. Baker's, fresh for everyone.
Choose from a great selection of digital coupons and use them up to 5 times in one transaction. Check our app for details. Baker's, fresh for everyone.